Okay, this is the Algebra 1 video lesson for the second half of 5.4 point slope form. So we're going to be writing and graphing linear equations using point slope form in this lesson. So continuing from our first half, this is problem 3. What's an equation from this line? So we have 2 points here, and we can figure out the slope from the graph, and we can put it in point slope form. So let's do that. Let's just grab a point. I think this one's probably easier to use. Y minus y1 equals m times x minus x1, and you can use either one. They both would give you the same equation. If you put it into slope-intercept form, we're going to just leave it in point slope form. So this is x1, this is y1. So y minus 4 equals, and then we need the slope, right? So let's go from this point. Remember, we always go left to right, so let's go up. We're going to have to go up to get here. 1, 2, 3, 4, 5, 6, 7. We're going to go up 7. And we're going to go over 3. So the slope is 7/3. So this becomes 7 over 3, and then x minus x1 is 1. So there is an equation of that line. It's an equation. So you could have used this line as well, right? Point as well. This would be y minus -3 equals 7/3 x minus -2, which would be y plus 3 equals 7/3 x plus 2. And so either of these work. They look at different, but if you distributed the 7/3 here and then added this 4, subtracted this 3, you'd end up with the same line. So it's the same line, just different numbers when it's in this form. That's why a lot of times on tests it always asks you put the line in slope-intercept form. But it didn't say that for this, so we're not going to do that. Okay, so this is for you to do on your own. Write the equation of the line above it with a different point. Oh, whoops. Looks like I already did it for you. So if you had done this, if I had done this one, then you would have done this one. But, oh well, did it already for you, just to show you it can be done 2 different ways, or however many points, infinite many ways, because there's infinite amount of points on that line. Okay, moving on. Problem 4 says this table shows the altitude of a hot air balloon during its linear descent. So the hot air balloon is, I'm going to draw a hot air balloon because why not? Here's the fire. Okay, it's a balloon. All right, and then there's a basket. All right, sorry, now I'm wasting your time. Okay, it's going down. And what equation in slope-intercept form gives the balloon altitude at any time? So this is slope-intercept form. So let's look for, I cut off this question. What do the slope and y-intercept represent? That's what this is asking. Represent. All right, sorry about that. Okay, so let's first, we don't have the intercept because that's when x is 0, so we don't have that here. So we can use these other points, like this is an x, so this is x1, let's call this x2, this is y1, and let's call this y2. So we can get we can get a line from it and then put it in slope-intercept form, and then talk about what it represents. So y minus y1 equals m times x minus x1. And our slope, remember, is the difference in your y's divided by the difference in your x's. So y2, so this is 590 minus y1 is 640 divided by 30 is my x2 and minus 10. So then 590 minus 640 is -50, and then this is 30 minus 10 is 20. So the slope here is -5/2, or -2.5. So, and then we can just pick either one of these points. There's 4 points actually, but we'll just use the one that's x1 and y1 because that makes it easier to plug in. So y minus 640 equals -2.5 x minus x1 is 10. And let's put this in slope-intercept form so that we can answer this question. And that means we're going to distribute this slope here. So y minus 640 equals -2.5x, and then -2.5 times -10 is going to be 25. And then we're going to add 640 to both sides. So y is now alone. We have -2.5x, and then plus 665. Okay, so now we have our slope. Well, we had the slope already. Slope. And then this is going to represent, right, this is rise over run, which is my y's or change in y over change in x's. So y's are altitude. So this is altitude divided by time. And altitude is in meters, and time is in seconds. So we're talking about meters per second here, and because this is over 1. So it represents and it's negative, so it's representing that the balloon descends 2.5 meters every second. Or 2.5, let's actually write that, meters each second. So that's what that's meaning. Okay, and then the y-intercept, the 665, that's at the start. It's always the beginning when x is 0, so time at the start of time. So the y-intercept means the balloon was, and y is altitude, was at 665 meters when it started its descent. Okay, so this question was asking a couple of things, this equation here, and then all of these words here. Right, what does the slope and y-intercept represent? Okay, and now it is your turn to try one. So see if you could figure out what the line is here in slope-intercept form, and then talk about what each of those represents, the slope and the y-intercept. Okay, actually, this doesn't say y-intercept, but I do want you to include that. Okay, so try this on your own and then check back for the solution. Okay, and here is your equation in slope-intercept form. Your slope is 1250, so that means each hour the tank gets 1,250 gallons more water. And the y-intercept of 820 means that it has 820 gallons in the tank at the start. All right, that's it. Time for practice. Enjoy.